Chemistry is a science of matter, including its property, composition and structure, how it changes and how it interacts with energy. It therefore concerns everything inside and outside our planet. That is why it's called a fundamental science. It is also called central science because it intertwines with other sciences. So if you have some question about what you see or what you feel, the odds are it can be answered by chemistry. You might ask, how could an insect walk across the surface of the pond? It is because of the high surface tension of water. And why the skies are blue? Colors depends on the chemical makeup of a substance and what kind of light it may reflect. Chemistry is all around us, and everything related to matter involves chemistry. Chemistry is so big, that's why it's divided in different branches: organic chemistry, inorganic chemistry, analytical chemistry, physical chemistry, and biochemistry. You probably heard before that everything around you is made up of matter. The books you read, your mobile phone, your iPad, the food you eat, and even your pet dog or cat. Matter is defined as anything that occupies space and has a mass. Mass is a measure of the amount of matter in an object. The space which a matter occupies is called a volume, which is why you can literally say that matter includes everything inside and outside our planet. Here are the fundamental states of matter. Solids, which includes your pencil, notebook, and your iPad. Liquid, which includes water and the juice that you drink. The third are the gases, which include the air that we breathe and the helium that we use to inflate a balloon. There are other states of matter like plasma, which we can discuss later on. We are sure that you have seen the periodic table before, maybe in your science class or in your chemistry class. It is a tabular display of the chemical elements arranged according to their atomic number, electronic configuration, and recurring chemical properties. On this video, we would like to show you how the present periodic table has been developed throughout the years. So sit back and enjoy as we travel through time. We discussed before the development of the periodic table of elements and explained that it was arranged according to their atomic number, electronic configuration, and the recurring chemical properties. But how do we read the periodic table? We will discuss each part and explain it further later. This is the name of the element, the symbol of the element, the atomic number, atomic weight, electronic configuration, and the crystal structure of the element. On the succeeding videos, we are going to discuss each of these parts to have better understanding. Let us discuss about the atomic number. In order to understand the atomic number, we have to first understand what is an atom. An atom is the basic unit of matter and the defining structure of the elements. But even being the basic unit of matter, it is also composed of subatomic particles. The dotted area is the central area of the atom called the nucleus. It is also composed of two subatomic particles, the positively charged proton, the uncharged particle neutrons, and surrounding the nucleus is the negatively charged electrons. Now what is an atomic number? Atomic number is the number of protons found in the nucleus of every atom of that element. For the case of helium, for example, it means that there are two number of protons inside its nucleus. We are now going to discuss about the atomic weight. But before that, we have to learn about the mass number. The atom is composed of subatomic particles. Inside its nucleus is positively charged protons and uncharged particle neutrons. Surrounding the nucleus is the negatively charged electrons. We have learned also about the atomic number, which is the number of protons found in the nucleus of every atom of that element. But what is a mass number? Mass number is the number of protons and neutrons found in the nucleus of the atom of that element. Have a look at boron-10 atom. The boron-10 atom has atomic number of 5, which means it has 5 protons inside its nucleus. It also has 5 neutrons in the nucleus, which gives it a mass number of 10. On the other hand, Boron-11 has 5 protons and 6 neutrons, giving it a mass number 11, which is what we call an isotope. We have learned that atoms of the same element may have the same atomic number but may differ in mass number. Such case on boron-10 having a mass number of 10, and boron-11 having a mass number of 11. This is what we call an isotopes. Isotopes are two or more forms of the same element that contain equal number of protons but different numbers of neutrons in their nuclei. They differ in relative atomic mass but not differ in chemical properties. Here are some examples of isotopes. The isotopes of hydrogen, prosium, deuterium, and tritium. The isotopes of carbon, carbon-12, carbon-13, and carbon-14. Have you seen anything like this before? This is the chemical formula for aspirin. But what is a chemical formula and why it is important? We encounter chemical substances and mixture every day such as soap, medicine, gasoline, and more, and these chemicals are made up of fixed proportion of atoms arranged in a certain way. A chemical formula is a short way to write out what atoms are present in a chemical. Take for instance a water molecule. It can be written as one oxygen atom bonded to two hydrogen atoms. Chemists came out with formula to write it in a shorter way. For instance, this molecule is represented by H2O, H for hydrogen and O for oxygen. It still looks pretty easy, right? But how about more complex substances like lactose, for example? Chemical formulas makes it easier and shorter. There are different types of chemical formulas: molecular, empirical, and structural formulas.